the system of equations. We must deal with them all at once. Always looking for solutions. Positive outlook overcome.
Hello, my name is Roy Simpson, professor of mathematics at Cosumnes River College in Sacramento, California. This video is a final video in a series on dimensions of vector spaces, or at least an introduction to dimensions of vector spaces for linear algebra students. We round out all these videos with a discussion about the dimensions of the null space of a matrix A and the column space of a matrix A. Notice how I was intentional with saying of a matrix A, because all previous videos in this series on dimensions of vector spaces did not really concern themselves with matrices, because that's an old school concept. Now we're dealing with abstract vector spaces that could involve polynomials, but we do know that we can find the change of coordinates matrix and therefore deal with matrices. So it is advantageous for us to have a conversation about the dimensions of the null space of A and the dimensions of the column space of A. So here's a good theorem for us. The dimension of the null space of A is the number of free variables in the equation AX equals 0, and the dimension of the column space of A is the number of pivot columns in A. That is not a definition, that's actually a theorem. It sounds like a definition, but it's actually a theorem. Remember, the definition of dimension is the number of vectors in a basis for a space. Well, think about the null space of A. It's all solutions to AX equals 0. And when you solve the homogeneous equation AX equals 0, the number of building block vectors in the solution to that equation matches the number of free variables. Remember, we had a theorem previously that stated the number of building block vectors, or the number of basis vectors, for the null space is going to match the number of free variables in the matrix equation AX equals 0. The dimension of the column space being the number of pivot columns in A, that should be obvious as well, because remember, the column space is generated from the columns of A, and all you need are the linearly independent columns of A, and those are defined by the pivots in A. So if A has 2 pivot columns, then the basis for the column space of A has 2 vectors, and therefore the dimension of the column space of A is 2. This topic is short and sweet and awesome. So let's just dive right into it. Determine the dimensions of the null space of A and the column space of A for the matrix given here. I'm not going to get too fancy with this. What I'm going to do is just create equivalent forms of this matrix A, so that I can find out how many pivot columns A has. Now I gotta be honest with you here. That matrix sucks. That's not something I'd really like to give to a student for any type of exam or anything like that. However, luckily I was able to speed up the video so I can go through all the stupid arithmetic there. Sorry, I didn't mean to seem so negative. It's just terrible. All right, you can see we have 1, 2 pivot columns. Thus, by our theorem, the dimension of the column space of this matrix is going to be 2. The 2 columns that generate the entire column space are these 2 columns right there. Those are the basis vectors for the column space of A. And we have 1 free variable associated with this column right here. Therefore, the dimension of the null space of A is 1. If you noticed 1 plus 2 is 3 and you had 3 columns, you are not alone in noticing something very nice. We will discuss that a little bit later on, but, well, I could just say it right now. The sum of the dimension of the column space of A and the dimension of the null space of A is going to be the number of columns that you have in your matrix A. But that's a theorem we'll mention later on because we don't need it right now. And that's it, folks. That is all you need to know for now about the dimensions of the null space of A and the column space of A. I hope this video is helpful, and I hope you have a great day. Be a superb human being.
It's the system of equations. We must deal with them all at once. Always looking for solutions. cause effects more than we can sometimes see. Things for what they are and work together until you feel at peace. Just listen close, don't talk too much that isn't cold. Sure, you may really hurt inside. It doesn't justify you to speak too loud and cry.